Assalamualaikum warahmatullahi wabarakatuh. This video is for subject ECM 366 Civil Engineering Quantities and Estimation. In this video, we are going to look at measurement of earthwork. First, we look at outcomes. So first we have program outcome, and then we have cost outcome, and lastly we have lesson outcome. Normally for earthwork, we are going to measure the process of cut and fill, and we have several methods to measure for the cut and fill. And normally we are going to use grid method. Another one we have cross-section method, and in this video we are only cover for the grid method. First, we look at definition for grid method. Grid method involves drawing a uniform grid onto a plan of the earthworks project and taking off the existing and proposed ground level at each node of the grid, and volume for each cell is obtained by multiplying the depth with the cell area. So the formula that student need to memorize if student use grid method is volume can be obtained by multiplying that with cell area. So we are going to apply this equation on later exercise. The accuracy of grid method depends on the size of grid cell. If you use a smaller size of the grid, and then you will get a higher accuracy, but it will become more tedious. So a compromise has to be made between accuracy and time consumed to produce the estimation. We are going to look at exercise 1. The question is, determine the volume of earthwork as shown in figure 1 by applying grid method. Provided here, the length is 5 meter, breadth is 5 meter, and the depth is 3 meter. Basically for this one, it's like this diagram here, whereby maybe this location is a flat area. So before we construct a house, they normally build a platform here. So they increase the level of the platform so that when the flood happen, their house will be safe. And normally in normal practice, the platform that are going to be constructed must have the slope here for the stability purposes. But in our case, let's say we have a flat ground here, we just assume that the platform without the slope. So the purpose is so that we can understand easily the concept for the grid method. Back to the question. Initially you have a flat land, and then you want to increase the level of the platform, so you need to determine the volume of earthwork needed. By using the normal mathematical formula, normally you can use volume equal to length multiply with breadth multiply with depth, and then when you substitute the value 5 times 5 times 3, you will get 75 cubic meter. So that is the volume of soil that you need to buy in order for you to have a slightly higher ground. Other than using the normal mathematical formula, we have alternative to use grid method. If we are going to use grid method, we convert this diagram here into this diagram. So this one is called as grid cell, whereby the area of the grid cell is 5 meter times 5 meter. Basically, the grid cell is the base of the platform that we are going to construct here. Right, so the length is 5 and breadth is 5. The length here is 5 meter and the breadth here is 5 meter. Then, if you can see, at every corner of this grid cell, there is a value of 3 here. Basically, it indicates the depth at every corner of the platform. So first here we have the 3 meter, so we put it at this corner. At this corner we also have 3 meter, we put it at that side corner, and then we have another 3 meter here and another 3 meter. So the value of 3 here, basically it indicates the depth at every corner of the grid cell. So remember the formula just now. If we are going to apply the grid method, the formula is quite simple. Volume equal to depth or average depth multiply with cell area. So now the cell area is this one. We can get by multiplying 5 with 5. So this is the cell area. And then the average depth, if you look at this grid cell, the depth is the same. So how to get the average? You just add 3, 3, 3, 3, sum up, and then you need to divide with 4 because you have 4 readings of the depth. So once you calculate it, you will get the answer is 75 cubic meter. Maybe some of the students think that the normal mathematics formula is more simple compared to grid method. So for those students who think mathematics formula is more easier and simple, maybe you should think again and try to solve exercise 2 by using mathematics formula. In this video, I'm not going to touch on mathematics formula for exercise 2, but I will use grid method to solve this problem. The question for exercise 2, determine the volume of earthwork in figure 2 by using grid method. So as you can see, now the depth at each corner is different, right? And if you are going to apply the grid method, we need to convert into the grid cell. So here we put the value of depth. Okay. So it will be like this. And then we apply the formula for the grid method, which is volume equal to average depth multiply with cell area. And then the average depth, we just sum up all of the value of the depth here. We have 5, 3, 2 and 4, and we need to divide with 4. And then we multiply with cell area. So the cell area is 5 times 5. And after we calculate, we get the answer for the volume is 87.5 cubic meter. Other than using a square grid, if you see here, for the first one, we use a square grid. Other than using the square grid, we can also apply triangle grid. So for the same question, exercise 2, we can now assume that we are using triangle grid. So if we are using triangle grid, we will have two triangles, which is triangle A and triangle B. And the formula is still the same. The average volume equal to average depth multiply with cell area. Right, so we need to determine volume for triangle A and triangle B. First one, we look at volume for triangle A. So we need to calculate the average depth. So for triangle A, we have the depth of 4, 5, and 3. So we sum up and then we divide with 3 because we only have 3 reading for the depth. After that, we'll multiply with the cell area. So the cell area is indicated here 5 times 5, and you need to divide with 2 because it is triangle. So the answer for VA is this one. And next, for VB, the same formula. The average depth, we have 4, 2, and 3. So we get the average, meaning that you sum up and divide with 3. And after that, you multiply with the cell area for B, triangle B. So which is 5 times 5. You need to divide with 2 because it is triangle. So you will get this value. To get the V total, you need to sum up VA plus with VB. So you get this value. Once you calculate it, you will get the same answer as the previous one, which is 87.5 cubic meter. So we have an option, either we want to use a square grid or we want to use triangle grid. Next, we move to exercise 3. So for exercise 2, we only have one grid, so it's simple. And for exercise 3, we have 4 square grid, so it will be more complicated. But the solution, the method of solution will be the same. So question for exercise 3. By using grid method, determine the total volume of earthwork in figure 3. Meaning that you need to determine the volume for A, volume for B, volume for C, volume for D, and then you sum up to get the total volume. And you still need to apply the same formula, average depth multiply with cell area. Please bear in mind, the given here, the grid cell is 50 meter times 50 meter. Basically, it refers for each cell. So it refers to this one, 50 meter times 50 meter. So just a simple example here, you determine VA, you determine VB, you need to determine VC and VD. After that, you sum up to get the total volume here. Next, we move to exercise 4. Damai Sendirian Berhad is appointed to complete cut and fill project for an area of 100 meter times 100 meter. So by applying tabulated format, compute the total volume of cut and fill for an area of 25 times 25 on the grid. So this is the cell, the size of the grid cell. As shown in figure 4, it is proposed to provide a platform for RL, a reduced level of 75 meter. You are also required to determine the volume of exported or imported soil, if any. Okay, so for this question, you are going to apply tabulated format here. So basically, tabulated format is a simplified method of grid method. And then the level that you want is 75 meter. So we look at the diagram 4 here, the figure 4. You can see the line here. So this line indicates the level of 75. And then the RL that you want is also 75. So this line basically is a border for the cut section and the fill section. So based on the figure of depth that we have here, we know that this side is cut. The reason is because original level, if you can see, is more than your desired RL 75. So meaning that this region you need to cut in order to get a lower level, which is 75, and this section will be filled because the original level here is less than your desired level, meaning that you need to fill this section to get a higher level as your desired. So we look at the solution. In order for you to use tabulated format, you need to apply this table whereby you have the first column is GP, it refers to the grid point, and then you have your height, mode factor, and weighting. As in the figure just now, we have two sections, which is cut and fill. So we are going to solve separately. For the first one, we are going to look at the volume of cut. Let's say we look at GP for the first one, which is GB1, which is the B1. Based on the figure 4, so you know this is B, this line is B, this is 1. So the intersection will be B1 here. So this point is B1. And you look at the level, original level, it is 75.9. Your RL, your desired level, is 75. So meaning that the height that you need to cut is 0.9. So you put inside of the table, and then you need to determine the mode factor. This is your B1. You need to count the number of triangles that touch this point. So first you will have this triangle, number 1. Then you have this triangle, 2, and another triangle, 3. So meaning that for the mode factor it will be 3. In order to get the weighting, you just multiply height multiply with mode factor, so you will get the weighting. Next, let's take a look on B2 for example. This one is B2. The height, it will be the original 75.5 minus with RL, which is 75. So the height will be 0.5. Next, you are going to determine the mode factor. So you need to count the number of triangles that touch this point. First, you will have this one, 1, and 2, this one, 3, and 4. If you look at this region, basically it not more than half. So once it's not more than half, so we assume it is 0. So the same thing for the region here, it less than half, so we assume it as 0. So for the mode factor for B2 is only 4. Okay, so to get the weighting, you just multiply 0.5 multiply with 4, you will get 2. Let's take a look on other example. For example, E5 here. So E5, E and 5, so meaning that the point is here. So the height will be 0.7 and the mode factor is only 1 because only one triangle that touch this point. So we look at the solution. The mode factor is 1. Let's take a look at GP A5. A5, so meaning that this is the point. So for so this one is for the field, so not yet calculated. Let's say for GP E1, so this will be the point. So for height 77.5 minus with 75, so the height will be 2.5. And for the mode factor, you will have 1 and 2 triangle. Right, so we look at GPE1, the height is 2.5, mode factor will be 2. So you will get your weighting. So that is for the card. So for the rest, you may be able to solve by your own. Now let's take a look for the field. Okay, so let's take a look for A5. So it will be this point. So your height is 71.7. Your desired RL is 75. The original is 71.7. Meaning that you need to fill for the height of 3.3. So this will be the height. And then for the mode factor, you need to count. So you have 1 triangle and 2 triangle that touch this point. So let's take a look for the solution. Okay, so for A5, the height is 3.3 and the mode factor is 2. So you will get the weighting 6.6. If you look at the mode factor, for certain point, it has more than one answer. So the reason for that is because the judgment for every of human is not the same. Maybe let's say for this example, for B4, when you count the triangle, some of the student may judge it as 4, some of the student may judge it as 5. So there will be a flexibility for the answer. So student no need to afraid about which one is right, which one is wrong, because both are correct. So next, after you have calculated for the table, you will get for the cut 74.4, and then for the fill you will get 25.7, and then you need to put inside of the equation. So for the cut, this is from your table 74.4. This is basically your cell area, and 6 is because we are using a triangle grid. And for fill, the same thing, 25.7 is from the table here, and 25 times 25 is the cell area, and the 6 here is because we are using a triangle grid. And then based on the question, student needs to determine the volume of imported or exported soil, if any. So based on our calculation, we determine that the volume of cut is more than volume of fill. Cut is more than fill, meaning that you have an excess volume of soil, so you can sell the excess soil, meaning that you have the volume of exported soil. So you just take the volume of cut 7,750, you minus with volume of fill, so you get the volume of exported. So I need to explain why you need to add this one here. So remember, tabulated format is a simplified method of grid method. So this value originated from the above example. We look at exercise 2 that we solve using the triangle grid. You can see here the value that you get from the table from tabulated format is just this value, and then you need to divide with 6 because for the exercise 4 we are also using the triangle grid, and then you need to multiply with this one is cell area. So from this concept, basically you apply to the tabulated format here, so that's why you have these additional numbers here. That's all for grid method. Thank you for watching this video. Hope students can understand the basic concept of grid method. Thank you very much.